Prep 2. Today we'll continue Unit 2, Lesson 2, Wave Nature of Light. We studied before in Lesson 1 that sound and light are two waves, but sound is mechanical wave, needs a medium, while light waves are electromagnetic waves that don't need a medium. So in this lesson we'll talk about light specifically. What's meant by light? It's one of the electromagnetic spectrum that has wavelength ranges from 380 nanometer to 700 nanometers. Okay, what's meant by electromagnetic spectrum? This is called electromagnetic spectrum. It's a range which contains all the electromagnetic waves, and the visible light is one of the electromagnetic waves. So it's found on the spectrum. We have gamma rays, X-rays, ultraviolet, and visible light that we can see, infrared, microwaves, and radio waves, 7 electromagnetic waves. But we can only observe or see one type, which is called visible light, that ranges from 380 nanometers to 700 nanometers, its wavelength. The velocity of light, to measure the velocity of anything, we have to measure the distance covered in 1 second. So what's meant by velocity of light is the distance covered by light in 1 second, which equals 3 times 10 to the power 8 meter per second in air. Okay? It differs from a medium to another. For example, light moves slower in glass than in air. Analysis of white light, the separation of white light into 7 spectrum colors. The analysis means the splitting or separation to separate the white light into the composition or its composition or into the colors that form the white light, which are called 7 spectrum colors, starting by red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow, green, blue, indigo, violet. Must be sequenced. Okay? By using a glass prism, we can separate the white light into 7 spectrum colors, which are red, orange, yellow, green, blue, indigo, violet. Okay? The nearest one to the apex is red color, and the nearest one to the base is violet. The energy of light. To measure the energy of light or to find the concept of energy, we have to know that any light is composed of photons. Okay, what's meant by photons? A specific amount of energy. A specific amount of energy which is called quanta of energy. So for example, red photon has quanta of energy different from green photon, from blue photon, from violet photon. Again, any light or any light color is composed of photons, which are specific amount of energy known as quanta of energy. To measure the energy of photon, Max Planck said that we have to use a Planck's constant, a specific number, times the frequency of the light. So to measure, for example, the energy of a red photon light, we have to make Planck's constant times frequency of the red photon. And so by increasing the frequency, the energy of photon increases as well. They are directly proportional. A very important point, that frequency is directly proportional to the energy of the photon. And by increasing the frequency, the energy increases as well. Blue has more energy than orange. Give reason. Blue color has more energy than orange or yellow because blue has more frequency than orange. More frequency, more energy. And as we see that red color has the highest wavelength, so it has the lowest frequency and the lowest deviation, which means the lowest refraction, and lowest energy. Lowest frequency, lowest energy, according to Planck's constant or the rule of Planck. Violet has the lowest wavelength, highest frequency, and highest deviation, and the highest energy as well. So from red to violet, frequency, energy, and the deviation increases while the wavelength decreases. So for example, blue color has more energy than red color, and the violet has the highest energy, highest frequency, and so on. We have three types of media according to the transparency of medium or the transmission of light through them. We have transparent medium, translucent or semi-transparent, and opaque, as we studied in Prime 5. Transparent medium, they allow most of the light to pass through them. Semi-transparent, they allow some of the light to pass through them. Opaque medium, they don't allow light to pass. Like glass, air, water. Like frosted glass, tissue paper, or flint glass. Like skin, leaves, iron, copper, wood, whatever. Light travels in straight lines. We can observe the light of the candle in this case, but we can't in this case. Give reason, because light can't make a curve. It moves straight. The light intensity, or the concentration of light in one point, means the amount of light falling perpendicular on a unit area in 1 second. So for example, in this case, most of the light is concentrated. Less concentration, less concentration. So by increasing the distance, the light intensity decreases. And the light intensity is inversely proportional to the square of distance, which is known as inverse square law of light. When distance increases to double, the light intensity will decrease to quarter, not to the half. Give reason, because light intensity is inverse to square of distance, not only to the distance. Inverse square law of light, light intensity is inversely proportional to square of distance, as we see. And thank you for watching. I hope you understood it.